In C and C-like languages, an array is a block of memory that stores a fixed number of elements of the same type. When you write the name of the array, for example int 5, in most expressions the compiler converts or decays it to a pointer to the first element. That is &0. This is called the decay rule. Analogously, think of a row of mailboxes. The row itself, the array, has a street address, but when you hand a letter to a post person, you give them the address of the first mailbox. The rest of the mailboxes are reachable by adding offsets. The decay does not happen when the array is the operand of siziof, _lignof, or the unary ampersand operator, because those contexts need the whole array, not just its first element. Example: int 4 is an array of 4 ints. Int star p equals a decays to &0, p points to a 0. Size t n equals siziof. Siziof sees the whole array, n equals 4 times siziof int. Int star q of array 4 equals ampersand a. Q is a pointer to an array of 4 ints, not to a single int. From this explanation, you just need to break them into segments, and for each segment return phonetic reading style of the segment. Pointer arithmetic works only with pointers that point to elements of an array or one past the last element. The basic operations are: addition p plus k moves the pointer k elements forward. The actual address change is k times size of p bytes. Subtraction p minus k moves backward by k elements. Increment p plus plus is shorthand for p equals p plus 1. Decrement p minus minus is shorthand for p equals p minus 1. Mathematically, if the base address is O and the element size is S equal to size of P, then address of P plus K equals a plus K times S. The compiler automatically multiplies by S, so you never write the multiplication yourself. Real-world analogy: imagine a train with equally spaced carriages. If you are standing at carriage 0, the first carriage, and you move forward 3 carriages, you will be at carriage 3 regardless of the length of each carriage. The train driver, the compiler, knows the carriage length and adds the correct distance for you. Explanation: to find the address of a particular element O of I using a pointer, start with the pointer to the first element, int star p equals a, and add the index I. Int star p equals a comment points to a 0. Int star iter equals p plus I, comment now points to a of I. Because of the element size scaling, the actual byte address is address of O of I equals address of O of 0 plus I multiplied by size of int. If it begins at memory location 0x1000 and size of int is 4 bytes, then O of 3 resides at 0x1000 plus 3 times 4 equals 0x100c. Example in code: int a left bracket 6 right bracket equals brace 10, 20, 30, 40, 50, 60 brace semicolon. Int star p equals a comment p equals ampersand a 0. Print double quote %p space %p backslash and double quote comma open parenthesis void close parenthesis star open parenthesis p plus 4 close parenthesis comma open parenthesis void close parenthesis ampersand a left bracket 4 right bracket close parenthesis semicolon comment. Both print the same address. From this explanation, you just need to break them into segments, and for each segment return phonetic reading style of the segment. Explanation: when you subtract one pointer from another that point into the same array, the result is the number of elements between them, not the byte difference. If p equals ampersand a left bracket j right bracket, and q equals ampersand a left bracket I right bracket, then p minus q equals j minus I, an integer of type ptrdiff t. The compiler divides the raw byte difference by size of star p automatically. Example: int a open bracket 10 close bracket, int star p equals ampersand a open bracket 7 close bracket, int star q equals ampersand a open bracket 2 close bracket, ptrdiff t diff equals p minus q diff equals 5. Mathematically, address of p equals address of a 0 plus 7 times s address of q equals address of a 0 plus 2 times s address of p minus address of q equals open parenthesis 7 minus 2 close parenthesis times sp minus q equals open parenthesis address of p minus address of q close parenthesis divided by s equals 5. This operation is useful for computing the index of a pointer. For example, int ix equals p minus yields the index of the element pointed to by p. Both classic for loops with I equals 0, I less than n. Increment I and pointer increment loops achieve the same effect, but pointer code can be slightly faster because it removes the multiplication needed to compute a indexed I each iteration. Indexing version. For size t, I starts at 0, while I is less than n. Increment I, open brace sum plus equals a indexed I, comment compiler translates to a plus I, close brace. Pointer version. For int pointer p initialized to a pointer end initialized to a plus n, while p is less than end, increment p, open brace sum plus equals dereferenced p, comment directly dereference the moving pointer, close brace. The pointer loop uses two pointers. P walks from the start to 1 past the last element end. No multiplication is needed inside the loop body. The address calculation happens once per increment p increment. Analogy: walking down a street, you can either count house numbers index and compute each address from the start slow, or you can simply step from one door to the next pointer, which is quicker. A multi-dimensional array is stored in row major order C language. This means that the elements of the first row are stored contiguously, then the second row, and so on. Row 0 colon M00 M01 M02 M03. Row 1 colon M10 M11 M12 M13. Row 2 colon M20 M21 M22 M23. If you treat M as a pointer to its first row, its type is int star left parenthesis star right bracket 4 right parenthesis. Adding 1 to that pointer jumps an entire row, 4 ints. Int star left parenthesis row ptr right bracket left bracket 4 right bracket equals M semicolon points to M0. Row ptr plus plus semicolon now points to M1. To reach element M left bracket, I right bracket left bracket J right bracket, using a single int star you can flatten the indices. Address left parenthesis M left bracket I right bracket left bracket J right parenthesis equals base plus open parenthesis I times COLS plus J close parenthesis times size of int, where cols is the number of columns, here 4. For a three-dimensional array, int t left bracket 2 right bracket left bracket 3 right bracket left bracket 4 right bracket, the formula extends. Address left parenthesis t left bracket a right bracket left bracket b right bracket left bracket c right parenthesis equals base plus open parenthesis a times open parenthesis 3 times 4 close parenthesis plus b times 4 plus c close parenthesis times size of int. The pointer arithmetic works the same. Int star left parenthesis p right bracket left bracket 3 right bracket left bracket 4 right bracket equals t semicolon and p plus plus moves to the next plane, 2 times 3 times 4 ints. Analogy: think of a book two-dimensional where each page has rows of words. The book is stored page after page. Moving to the next page jumps a whole block of rows. A three-dimensional array is like a stack of books. You jump whole books when you increment the outermost pointer. Out-of-bounds access. Adding an offset that goes past array plus size is undefined. Even p plus size, one past the last, is allowed only for comparison, not dereferencing. Type mismatch. Pointer arithmetic uses the size of the pointed to type. If you cast incorrectly, the scaling changes and you land at the wrong address. Example: char cast p plus 1 moves 1 byte, while int cast p plus 1 moves size of int bytes. Operator precedence. Star p plus plus is parsed as star open parenthesis p close parenthesis, not open parenthesis star p close parenthesis plus plus. Likewise, ampersand star p simplifies to p, but star open ampersand p plus 1 close parenthesis is illegal because ampersand p is a pointer to a pointer. Missing parentheses. P plus I times j is p plus open parenthesis I times j close parenthesis, not open parenthesis p plus I close parenthesis times j. To add two offsets you must write p plus I plus j or p plus open parenthesis I plus j close parenthesis. Confusing array name with pointer. Sizeof gives total byte size, while size of star gives size of one element. Misusing these leads to wrong loop bounds. Remember, the compiler hides the multiplication by element size, but you must still think in elements, not bytes. 1. Predict outputs. Int of 5 equals 5, 10, 15, 20, 25 semicolon. Int star p equals a plus 2 semicolon. Print %d space %d backslash n comma star open parenthesis p minus 1 close parenthesis comma star open parenthesis p plus 2 close parenthesis semicolon. Solution colon star open parenthesis p minus 1 close parenthesis star accesses a open bracket 1 close bracket equals 10. Star open parenthesis p plus 2 close parenthesis star accesses a open bracket 4 close bracket equals 25. Output 1025. 2. Evaluate expression. Int b3 by 4 equals open brace 1, 2, 3, 4 close brace, open brace 5, 6, 7, 8 close brace, open brace 9, 10, 11, 12 close brace semicolon. Int star q equals ampersand b open bracket 0 close bracket 0 close bracket semicolon. Int val equals star open parenthesis q plus 3 star 4 plus 2 close parenthesis semicolon. Solution colon row major flatten index equals 3 star 4 plus 2 equals 14. The 15th element 0 based in b is 12, so val equals 12. 3. Convert indexing to pointer form. Original colon sum plus equals matrix open bracket I close bracket open bracket j close bracket semicolon. Int star open parenthesis row ptr close parenthesis open bracket call close bracket equals matrix plus I semicolon. Sum plus equals star open parenthesis star row ptr plus j close parenthesis semicolon. Explanation colon matrix plus I moves to the ith row. Dereferencing once gives a pointer to the first element of that row. Adding j reaches column j. These examples test understanding of decay scaling row major layout and the difference between star p++ and open parenthesis star p close parenthesis plus plus.